My name is Sergey, and today I'm gonna extend the topic of modularization. And I've been working a long time on projects of different scale, in teams of different sizes, for companies of different domains. But now I'm working at ABN Amro on the personal banking app, which some of you here, I suppose, may have on your iPhones and even on your Android devices. Okay. Let's take a look at what we'll be covering today. We're going to talk about the different approaches to modularization that I personally experienced and the tools that I used, because I don't want to just talk about something that I read on the internet, only about something that I have first-hand experience with. What else? We're going to take a brief look at alternative build systems or solutions of a similar kind and how we at the bank evaluated them. And we're also going to take a look at the common pitfalls when it comes to modularization. And of course, I'm going to raise the curtain and show you a little bit of ABN backstage. And a quick disclaimer before we go further, I am not going to give you the one and only solution that is applicable to all kinds of projects, because unfortunately, there's simply no such thing. So, let's get to work. It wouldn't make any sense talking about the topic without answering the most important question. Why do we need modularization, and when do we need it? But before we go, I want to ask you a couple of questions. How many people here have worked with monolithic iOS apps? Nice. How many people here have worked with modularized iOS apps? Wow, tough audience. You know it all. OK. Raise your hands, those who like the monoliths better than the modularized ones. Don't be shy. I mean, come on. There's got to be someone. No? OK. So I assume that you all like modules. OK. A couple memes and funny pictures, and then we go. Let's pay respects to the times when there was no Swift. The projects were small, the teams were pizza-sized, and back then, buying a more powerful MacBook or iMac, or even a Mac Pro if you were rich, seemed like a good idea. Unfortunately, now it's not the case. Vertical scaling, aka buying new hardware, can only get you so far, and at some point you will get stuck with the slow builds and you will be limited by the technology of your time, like this dude. Then the only thing left for you will be horizontal scaling, aka modularization. But build time is not the only benefit. The benefits are that you will get a second chance to take a look at the code base and see which architectural approaches work and which don't, which flows of your app are well isolated from the rest of the code base and which need refactoring. And as a bonus, and today we're going to talk about lots of bonuses. You get a bonus, you get a bonus, everybody gets a bonus. So you will probably find quite a few dead classes that can be easily removed. But what else? Merge conflicts. They are inevitable if you have a bunch of dynamic developers that are working on the same Xcode project or a workspace on a daily basis. But if you modularize your app, there's a high chance that people will not get in the way of each other or do so less often. And yes, with Xcode 16 buildable folders, it's less of an issue. True, but it's still an issue. What else? Observability. It's important, and it may be challenging to assign ownership of some piece of code when it's monolithic. But when you have modules, it is easier to draw the border between teams, and it's also a great benefit for engineering leaders. Do we have engineering leaders here? OK, developers only. OK, but just in case you are about to be promoted, now you can collect all kinds of metrics with ease. To-dos per module, technical depth per module, code coverage per module, PR lifespan per module. Well, anything that you can imagine and anything that you can want to measure per module. What else? Swift, this birdie. It is evolving as crazy, and we, as developers, we need to be on a constant lookout for the new features and check our projects earlier. And now we have an option to enable experimental flags or set different levels of compiler strictness. And yes, I'm talking about Swift concurrency, which is one of my favorite topics, but not for today. But we're going to talk a couple more minutes about Swift concurrency. Imagine you have a big app with dozens of screens, and you start migrating to the Swift concurrency. And as many do, you forget to enable the concurrency check. And at some point in future, one of your colleagues or you enable this compiler check, and the whole project just breaks. Ouch. Then you are tempted to disable the check and continue doing whatever you're doing. Don't do that. With the modularized project, however, it is easier to check and migrate the app bit by bit. And now we can also enable Swift 6 in some modules while leaving the rest of the code base in Swift 5 mode. And yes, there are common gotcha moments, but it is still possible. And it's pretty nice, right? It's not that obvious point of modularization, but it's an important bonus. And now you may say that, well, it is too good to be true. There must be some catch, a price to pay. And now let's talk about the challenges. First and foremost, how do I split my project into modules? That's the most important question that you will come with. And then, along your journey, you will find a term, transitive dependencies, and you will be asking, what's that? So imagine we have a module that has a dependency, and that dependency has other dependencies. And by this, we have transitive dependencies. And they are not necessarily a bad thing, but sometimes they are. So how do I handle those? And how do I make sure that I won't end up fighting circular dependencies? And our code base is getting bigger and bigger. And when we have a monolith, it is easy to instantiate a service or repository or a data provider. Well, whatever you want to instantiate, you just call an initializer, right? But now it's not the case. Where do I register my services and stuff? Which part of the app is now responsible for that? And again, the app is getting bigger and the number of modules is getting bigger and bigger. How do I make sure that my binary remains lean, my dependencies, they don't link twice, and how do I prevent my modules from becoming as bad as my monolithic app? And a cherry on the pie. How do I organize testing? The resources, the mocks, the stubs, and all of that. And now we're going to go through some of those concerns. We don't have time for all of them, and I suppose no conference talk or even a podcast can fit the topic. So let's talk about the approaches to modularization. And let's imagine that it's a game. And since one of my favorite games is Deus Ex, we're going to start with an easy mode, which is going to be called Tell Me a Story. And I'm going to tell you a story. So you have a project. And in any project, you probably have folders that are called shared, common, extensions, networking. Ring a bell? OK. So those are perfect candidates for moving to separate modules. Let's call them the core and move to separate frameworks or packages, whatever. We can leave the UI flows in the main app target, and that's it, end of the story. But will you benefit much from it? It really depends. This approach is like a low-hanging fruit. You start thinking about reusability and connections between the components of your app. You start arranging the moving parts in order, and in result, you get a bit faster builds, but only a bit. And this approach works really well when you have a small team and rather small, maybe up to medium-sized app. So if you have one or maybe two teams, this can be a solution. And this will also enable you to get to know your code base better and see the weak places and the places that need refactoring. And after all of that, you may be tempted to play the game again, but on the next difficulty level. Give me a challenge. So now, your reusable logic is already in separate packages and modules, and that's fine. But go further and modularize it even harder. Extract the domain layer and extract the architectural pillars into packages. Then leave your existing modules in the main app target if you don't want to touch them or if it's too hard to refactor and modularize, up to you. But for any new feature, for any new flow, start with the micro app. Add a new package that should consist of several targets. A platform-agnostic business logic, we can call it a feature core, and a UI target for each of the targets that you support. iOS, watchOS, macOS, maybe visionOS. Anybody supports visionOS? Okay, I see the hands. Nice. Okay, and of course, we write tests to be confident that we're not breaking stuff, right? So there's going to be test target. But on top of that, create a sample app that will be connected to this feature, to this module, and also it will be connected to the domain and probably some utils. And in this case, your team will work in this module. The team will work in silo, isolated from the main project, without having to build it over and over again. And it really enables you to move faster. I introduced this approach to one of the travel scale-ups here in Amsterdam, and it allowed us to move on without rewriting half the app. And we worked on pretty complex redesign. In our case, Swift Package Manager was a tool that we used, and our main app target became an orchestrator. It was the place where we registered all our dependencies and injected them into the flows. And it was also a place that handled the high-over navigation. The rest was handled privately in the feature frameworks. It does require more effort from the teams, but in return, it gives you the flexibility and the velocity for the new developments. And this approach works really well with medium-sized apps and medium-sized teams. But what if that is not enough? Then let's play the game on the last level. Give me full modularization. But before we start, as promised, let's take a sneak peek at ABN Amro. The app is older than a decade, and currently we have about 40 developers working on it. And the codebase is a mixture of Swift and Objective-C. Of course, Swift is prevailing, but still we have some. And 4 years ago, it was a huge monolith that took up to 15 minutes to compile. And even the most powerful Intel machines would get crazily hot and they would start throttling. And back then, the engineers decided that, well, it's not going to work anymore. It's not sustainable, it's not scalable, we need to do something about it. And of course, they needed to do some modularization. But when you have a few million lines of code, it is hard to just move things around. And it's hard to decide what code is reusable by everybody and what code belongs to one specific team. There must be some sort of structure, right? And I give you the one and only, joking, ABN Amro structure. So we have 3 levels of modules or framework. The shared ones are the ones that can be used and reused out of scope of the personal banking app. We have some building blocks like design kit, networking, some security stuff. It's all on the shared level. Then there's a core functionality. The core modules, they can have shared modules as dependency and other core modules as dependencies, but those things are not feature specific. They are specific to the domain of the personal banking. And then, on the last level, there's a feature. Features are owned by feature teams, and they can reference both core and shared modules, but they must not reference other features. Why not, you ask me? Well, if we allow that, we will end up with circular dependencies very soon. And the build graph will be broken, the project won't compile, we will have to resolve it somehow. So, all our teams, they own from 2 up to 8 and sometimes even more modules. Feature modules, I mean. And eventually, they end up with some code that they need to share among those modules, but that code is not suitable for core or shared. So, we have added one more layer to this modularization rule, and now it's not that straightforward. Okay, so every team or a group of teams can have their privately shared frameworks that can be referenced from feature modules. And other teams or group of teams must not use those privately shared modules. If they do need it, then it's time for a discussion whether this functionality belongs to the core layer or not. But what if one of my features needs access to a feature of another team? It is inevitable, and it's all right. There are a few approaches to that, and one of them is to make the main app target an orchestrator, as we discussed before. But if you have dozens of modules, or even hundreds of them, this does not scale. What else can we do? We can create another module, a core module, that will contain only the public interfaces of the features. In other words, it will only contain the protocols and flow arguments. And this core module will be referenced in all our feature modules. And whenever we need to open one feature from another, we import the app protocols and use the public interface. And yes, I already feel how some people here have questions like, how does this work? And won't your app protocols become a huge dump of everything? And I'm going to answer this second question first. Yes, this module becomes a dump. And this is how it happens. So you put there everything related to cross-modules communications. Each module gets a folder and a file, maybe a couple of files. And each module links the protocols, and the project graph gets messy, like really messy. And in the end, one small change to this module leads to the whole build, cache, and validation. And now your modularization is officially broken. You are back to square one. How do I prevent this? As silly as it may sound, one of your worst enemies is delegation pattern. But let me explain first. In our project, we use something like Clean Swift and coordinators for navigation. And the protocols for coordinators go to the app protocols module. But we also need to receive callbacks from our flows somehow. And here's where many people are tempted to use good old delegates. And the protocol, the delegate protocol, is also placed in the app modules. It is a public one. And just like that, we get one more type in the core. But we could have avoided it if we used closures for our flow communications. Because in most cases, our flow is just it uses just a completion handler with no arguments. But it may also return something. In this case, these structures representing the result of the flow will also reside in app protocols. And this module becomes a dump of everything again. But sometimes when you have chosen a certain course, it is hard to change. And especially in the large-scale projects and in large companies. So for the time being, we have come up with a few rules. So this app protocols module can only contain the protocols that are required for cross-module communications, and structs or enums that come with those communications. And no implementation of any business logic can ever enter this module. But these rules, they only help to contain the problem. They don't really solve it. How do I fix the problem? Let's agree that it's a very rare thing that one feature module needs access to all other features. Most of the times it's just one or maybe two. So let's ban the app protocols and let's apply the interface segregation principle to each of our features. The idea is not new, and many people have talked about it and implemented it with their own flavor. I'll just briefly explain the concept, okay? So instead of having a monolithic feature module, you split it into two parts. The first part is going to be a public API that will only contain the inputs and outputs of the feature, and the private implementation is going to be placed in the second part of the module. And then there's a new rule. You can never reference the implementation module by any other module, only the interface. And the only place where the implementation is linked is the main target. This way, you won't have to recompile the dependent modules when something changes in the implementation, only when there's a change in the interface. And now it's time to answer the second question. How does this work? Well, this modularization can only happen if you have some sort of dependency injection framework. There are a few common solutions like Swinject, Needle, Factory, Typhoon. Is there anybody who remembers good old Typhoon? Yeah, old-timer. Okay, but it doesn't really matter which way you choose. You will need some framework that will provide a way to register all the dependencies and hold things together. And of course, there are in-house solutions in many companies. And many people choose the main app as a place to do the registrations when the app starts. Sounds reasonable. Other people, they extract this registration thingy in one more layer. It doesn't matter. Whatever makes you happy. So, just summing up. By this, we declare that the concrete or implementation modules cannot depend on each other, right? Only the lowest app module will know about them and register everything when the app starts. And when a feature module requires access to a feature in another module, it always reaches out to the dependency injection engine, asking it to resolve the dependency and then inject it into the feature. And since we have touched the topic of tools, let's talk about the tools. About the tools and the important aspects that we need to keep in the closed site. Ideally, before starting any work, we want to make sure that the results are measurable, right? What do we want to measure? First and foremost, for the developer experience, we want to measure build time. Clean builds and cached builds are important. Make sure that you have written some automation scripts or incorporated something like Metrics by Spotify. Then you will get the dashboards with the health status of your project, and you will see how your modularization affects build timings. It may also highlight some bottlenecks. And another life hack from us, pre-compile your assets and distribute them as an XE framework. It is totally worth it. What else? Binary size. It is important for your users and for you as well. So, during modularization, you will have to choose between dynamic and static linking for your modules, and these things, they both affect binary size and launch time performance. There are common pitfalls like duplicated symbols, launch time increase due to the number of dynamically linked modules that DYLD has to load and align, and of course DYLD is evolving and now it's not that big of an issue, but still. If you are hesitant which way to choose, reach out to Emerge Tools blog or Emerge Tools instruments because they provide fantastic insights for your apps. It is not an advertisement, but it could have been. So if anybody from Emerge Tools is here, reach me out. So, binary size and build time. These are the two metrics that should be tracked, and they will give you some sort of a pulse check whether you're going in the right direction or not. But what about the aspects that are hard to measure? I'm talking about maintainability and scalability of your solution. Now, your project is getting bigger and bigger, and you have lots of modules. And each of your modules has some settings, right? And XE config for the win. Because it is hard to keep track of your settings. Extract all the important stuff, move it to XE config files and use them. And also emphasize that from now on, you don't change individual projects for your settings. You put everything to XE config files so the rest of the teams can benefit from it. Speaking of individual projects, how do I create them? Because, well, the project is evolving, there's going to be only more modules, right? This is a boring process and error-prone. So the most simple solution that we have is Xcode templates. Those will make sure that the new project is respecting the file system agreements, uses correct XE config files, yada yada. But if you use Swift Package Manager as your modularization tool, then you will have to create some sort of custom scripts that will do the same for you from the command line. And you may be tempted to use sorcery and stencils to bootstrap the module creation. But with Swift Package Manager, you will still have to have an Xcode project file per module if you want to have sample apps, of course. And at this point, we have all our Xcode project files stored in the repository, meaning that we have as many files as many modules we have. And this will lead to weird Xcode artifacts, like whenever you're migrating from one Xcode version to another, you need to update all your Xcode projects because they also contain the version. And also, the merge conflicts are nasty, right? You will likely have broken links here and there, that code that is in the repository but not in the project. Nobody likes that. So, what are our alternative solutions? We don't have many options, to be honest. All of our options are circling around the idea that we need to get rid of Xcode project files and we need to generate them ad hoc. And to pull this one off successfully, we need all our modules to obey the same structure, the same file structure and the same XE configs. And we also need a replacement to the Xcode project format. And those replacements will be an input to Xcode project generators. and there are some options in the industry. Some of them are very brave and they require tectonic shifts. Others are less demanding, and we will start with the easy ones. Again, easy mode, tell me a story. So here's the story. I once worked for a company where we had like 70 modules, and we decided to get rid of our Xcode projects. We replaced them with YAML files, and we generated the projects via Xcode Gen tool. We added Git hooks that would regenerate the Xcode projects whenever we pull the new changes, and it worked fine. But does it sound good to you? What if I tell you that in a few months, the whole project was converted to Swift Package Manager? Coincidence? I don't think so. So, speaking of SPM, this thing was introduced as a dependency management tool first, but very soon people started using it for modularization, and it's great. It works fine most of the time, but when it doesn't, you are in a dead end. And again, if you need micro apps for your feature modules, it is not a solution to Xcode project problem. But what can be a solution? Here comes the heavy artillery. Alternative build systems and solutions of a similar kind. Most, if not all, big tech companies will tell you that, well, we have given up on Xcode long ago. And for a very long time, there have been only two options, Bug by Meta and Bazel by Google. But now it's part of native foundation open source, which is also great. So those solutions are cross-platform, meaning that they are not iOS exclusive. You can build projects for a lot of platforms using these tools. You can build Python, Java, C++, .NET, Swift, well, whatever is on the market, you can build it with Bazel or Bug, probably. But those tools, they use their own ways to organize and build the projects. They use their own ways to organize the build graph. They build it with their tools and link them all together in their own ways. And of course, they still use some platform-specific tools for certain operations, but you will not be dealing with them. You will be dealing with abstractions that are made so you can describe the projects using a cross-platform language, which is Starlark. And the Starlark manifests are usually more lightweight than Xcode projects. With a special command, you will generate an Xcode project from the manifest, and you will continue using Xcode as before. But Xcode will be just a front from now on. Building process will not happen via standard Xcode build commands. It is cool, it works very fast, but at the same time, it's very complex, and you need to go all in on that solution. It also requires to have at least one engineering team with quite deep knowledge of build systems, and that team will be constantly occupied with maintaining and improving the solution. Most of the times, there will be more than just one team, so it is quite an investment. But if your business depends on it, then yeah, it's probably worth it. And a few years ago, Twist was created. And one of its features is the fact that it's not cross-platform. It's all about Apple Stack, and it adds some flavor to caching and dependency graph resolution. And Twist team, they have transparency in mind, so they build everything on top of the open source. And yeah, they have quite impressive tools. And the learning curve is not as steep as with Bazel or Bug. And as a bonus, again, bonus, you define the project structure in Swift. And nowadays, Swift is the first language for many iOS developers. And because Twist is based on native Apple Stack, one more bonus, last one, I promise. If, for some reason, you decide to get rid of the solution, you just generate the project one last time. You commit them into your repository, and that's it. End of the story. The question is, how do I choose between them? And it's a very complicated question. Depending on the project, depending on the processes that you have in your companies, the answer may be different. Sometimes the requirement will be such as, we need one solution that fits all. Then it's either Bazel or Bug. Other times, it may be like Android folks are happy with their setup, backenders are happy, they don't care about your shiny tools. then you will be really tempted to stay in the native world of Xcode build and twist. Of course, we should not forget about the solution's maturity and many other aspects, but in any case, we need to do some sort of evaluation. How do we do that? We need to compare those tools, right? And it's really helpful if we have micro apps or sample apps, so we don't have to migrate the whole project all at once. You still remember Xcode Gen from a few slides before? So the easiest solution to evaluate those tools is to have an intermediate representation of your modules in YAML or JSON format. Then we create a script that will translate those YAMLs into Twist project files, Bazel build files, or bug build files. So a little bit of meta programming, and you will have a nice overview of what those tools can do and what those tools can't. Then you can give it a try in a micro app and see how it affects the productivity of one or even couple of teams. And in the meantime, I'm sure you will find lots of issues with the configurations, with the dead code, with your Fastlane scripts, with test plans, with the resources. Well, you will find lots of issues. And after all of that, you will be ready to make a decision, and I can almost guarantee you that it's not going to be an easy one. The question is there any other way? There is, or there isn't, I don't know. But besides working at ABN, I have my own project, and it's a small one. But as any geek, I decided that my project cannot live without alternative build systems and modularization. From one tiny Swift package with one executable, it became an app. And I did everything initially with Swift Package Manager, and the file system was identical in all my packages, so it was really easy to start migrating to other solutions. And I picked Twist and Bazel, just because I felt like Twist and Bazel. Now, I will give you a couple of tips and tricks which helped me in my research. Documentation. It's the key. But sometimes it's too much of information. Then explore the open source projects on the GitHub, because there are projects that use both Bazel and Twist, and you can use them as a source of inspiration. What else? I talked to ChatGPT a lot when I explored the Bazel, and don't cancel me, engineers. It helped me greatly, but I gotta confirm that there was a lot of noise and hallucinations out of ChatGPT. But it helped me, so give it a try. Speaking of Bazel and Buck, if you're looking into them, make yourself comfortable with VS Code, because VS Code is a great text editor. It also has integration with both Bazel and Buck, and it has integration with Swift Build Server, and in theory, you can continue working on your iOS projects without having to open Xcode at all. There is a plugin now that does all the routine for you. I don't remember the name of the plugin, but it builds the project, it launches a simulator, it deploys your IPA to the simulator and connects the debugger. So give it a try, but I don't remember the name, unfortunately. So the commands of both Twist, Bazel, and Buck, they are lengthy and error-prone. Create makefiles with shorthands for commands. The makefiles will save you lots of time. And now it's time to take a look at my project. It's not an advertisement. It's not published. So this is how the vanilla SPM solution looks like. Everything is a package. The main app target is an orchestrator. It links everything. It registers the services. It handles the high-over navigation. It's pretty simple and neat. But I'm not going to show you the Swift package manifest, because I'm sure that you have seen all of them, written dozens of them. Instead, let's take a look at Twist. Looks familiar, right? So, on the left side, you see something very similar to Swift package manifest, except for this is a Twist project manifest. It is written in Swift, and it compiles into an Xcode project file. And you can describe your project in a few lines of code. The rest will be generated for you. And on the right side, you see the whole workspace that was generated out of the projects like this. And in this case, the project looks like a traditional way of creating frameworks, the one that we as a community have been using since the beginning of the iOS era. Every package that I had become a framework, and I am the one who chooses if it's statically or dynamically linked. External dependencies, they didn't have any changes. I used SPM to fetch Firebase. It's still managed via SPM. And the best part is that no changes to the code base had to be made to make this transition possible. But now, let's take a look at Bazel. Again, on the left side, you see the same module described in Starlark, and it's way shorter than SPM or Twist. But it's a different language, it's a different IDE, it's VS Code, and we see that it's a different product. It's a Swift library, not a framework. Doesn't look like a package. Well, it's a static library. But it's compiled by the rules that are part of Bazel universe. And on the right side, you see the workspace that is generated out of the Bazel manifest. Here, everything is a folder, and we only have one root project. External dependencies are managed by Bazel. So, for each of your dependencies, you will have to make sure that there's a wrapper or an official integration with Bazel Toolkit. There have been no changes to the project, well, no changes to the code base, but I had to reinvent the way I organize the configurations because Bazel doesn't play along with the xcconfig files. Maybe I did something wrong. If I did, then yeah, we can have a talk later. Last but not least, don't forget that the Xcode that you see here is just a front. It's just a fancy or not so fancy text editor. And now is the time for a summary. If you ask me which approach is my favorite, to be honest, I would still go with Swift Package Manager for my project because it's small. But for a bigger project, I would probably go with Twist, unless my managers tell me that we need to share the build system with Android or backenders. If you haven't modularized your projects yet, but I suppose you all have, give it a try and start simple, and always keep in mind the exit strategy. What if things go south? What if one tool just breaks? Think of the exit strategy. Now, if you have some cool stories to share or life hacks, you are more than welcome at our stand there. Well, out of this area, but there. If you have questions, go ahead and ask, because we have a few more minutes, and I hope I will be able to answer them. If I am not, then we can take it backstage. Thank you for your attention. Thanks for listening. Have a good day.